Hey, how's it going? It's Bruce. I'm going to show you guys how to do some solve for the fundamental periods of continuous time signals with two quick examples. The first example is just going to be a simple one displaying the cosine of 2 pi t and how to get its period. In the period, first you can see that w is equal to 2 pi, and then 2 pi f equals w, so then f is going to be equal to 2 pi over 2 pi, which is equal to 1, and t is equal to the inverse of frequency, which is going to be 1 over 1, which equals 1. It's going to be in seconds. It's going to be inverse seconds or hertz. It's going to be a rad per second. Then the next example is going to be cosine of 2t plus cosine of 3t. First, start with the first term. W is going to be equal to 2. F is going to be equal to W over 2 pi, which is going to be equal to 1 over pi. And T is going to be equal to the inverse of that, just be pi. Then you can solve for the second one. This term here, you see W is equal to 3. That meaning that F is going to be equal to 3 over 2 pi. And then t is going to be the inverse of that. It's going to be 2 pi over 3. Now these are two different periods, so we're going to need a proportion or ratio of them, starting with the second period over the first period is equal to m over n. Then plugging in period 2, and then plugging in period 1. You see this equals, these cancel. You see it's going to be equal to 2/3, equal to m over n, meaning that m equals 2, n equals 3. Then going back to the beginning and cross multiplying from this portion here, you see t2 times n should be equal to m times t1. Then plugging in our values of t2, m, n, and t1, we see that should look like this, which is then going to be equal to 2 times pi. And these two cancel, and that's left the same, and you're left with 2 pi equals 2 pi, which is then the fundamental frequency of your signal. And that is all. That is how you do this.